So for 17 and 18, they asked about the measures of center and spread. Which measures of center and spread describe each data set best? That's something that I might have mentioned, but I don't think I mentioned it in every single class. So when I first saw this, I thought they were just asking you to draw a box and whisker plot, but that's not what they're asking actually. What they're asking is they want to know, do you use the median and quartiles, or do you use the mean and standard deviation of its, do you use that to measure the data? Okay, so do you use the mean or do you use the median? So we talked about how when you have outliers that using the mean is not very good because, for example, if Bill Gates moved into your neighborhood, all of a sudden everyone on average is a millionaire. And that doesn't make any sense. So what happens then is that you don't want to go with the mean if you have something that's clearly skewed either to the left or right. So here's what I did. When I ask you this question, you will not have to plot it because plotting histograms is something very rarely used on the TI-84. So let me just show you what it looks like first. Okay. So let's okay. So this is the data for 17. All right, I believe. Let me just double check. L1, yes. Okay, so go back there. All right, so this is the data for 17. What would you call this? Is this a skewed right, skewed left, or is it normal? Is it centered? And the answer is it's kind of skewed to the left, right? Skewed to the left. You can see that more data is over here and less data over here. So this thing kind of goes in this direction. More data is over here, okay? And so what you would say then, if you were to see this, is that this guy, because his graph essentially kind of looks like this, okay, that what you would want to do in this case is actually use the median and the quartiles. When you have data that is skewed to the right or the left, you want to use this as the center of your measure, okay? And for things like our next one, we're going to go ahead and change the plot here. Instead of using L1, I preloaded these, by the way. Let's use L2. So now we'll do a zoom stat. Okay, so this guy is definitely skewed to the left as well. Okay, so this guy also would be a median and quartile display. Now an argument could be made looking at this is definitely more skewed to the left. Okay, if we looked at the first one more time, you could make an argument that maybe this one is not so skewed to the left. Okay, maybe this is more central. And yeah, you could make an argument. This is kind of an interpretation thing. Of the two, this one, you could use the mean more so. Okay, you could use it more so. So 17 compared to this guy, we might say that this guy can use the mean and standard deviation. Okay, but that's pretty much your choice. You go median and quartiles or mean and standard deviation. Okay, the more central it is, like that, then you would use this group. Okay, all right, and that's it. That's it for 17 and 18. All right, now I'm not going to give you a data set. I'm just going to give you a picture. So if you see based on the picture something that looks like this, you know you want to go with mean standard deviation. You see something that's a little skewed to the left or a little skewed to the right, you want to go with median and quartiles. Okay, so let's look at 19. Describe a situation that could produce a data distribution similar to this one. Okay, now this one clearly using the mean and the standard deviation would not be sensible. Okay, because you could end up over here with your mean, even though most of the data kind of falls in here. Okay, you got some stragglers here, but it looks like the mode is actually here up at about 1.5. Now who knows what this means? It's not labeled. So what do you think would be kind of skewed to the left? Well, think of something that happens relatively rare. Okay, somebody in the second hour brought up speeding tickets. Okay, sure, this makes sense. Maybe speeding tickets over 10 years. This seems perfectly reasonable. Are there exceptions? Could you have somebody with 8 speeding tickets? Yeah, before they lose their license, sure. But there's all kinds of examples. Okay, so I'm keeping a very open mind for you to kind of label what you think. I might ask you for something that is skewed to the right, or something that is what's called bimodal, where it's got 2 humps instead of just 1. All right. Okay, so finally, number 20, a data set has a mean that is equal to the median. What is the likely shape of the distribution of the data? If the mean equals the median, well, then what you have is a normal curve. Okay, I'm just going to use this picture here. The normal distribution means that the mean and Q2, or the median, okay, basically line right up. Okay, and when they line right up, that allows you to actually use the z-scores and the z-table that you guys are going to use in the next section for normal distributions. Okay, it means these guys line up, and so you can use those tables. You can't use those tables when you've got skewing to the right or left.